So organisms have energy budgets. They obtain energy from their environment. And remember that when we obtain energy from our environment, it is inefficient. That was the second law of thermodynamics, where we talk about how during an energy conversion, we always lose some energy and it becomes energy that we cannot use. So like, for example, heat. So for example, when I eat something, it could speed up my metabolic rate and I could actually sweat and I could actually release some of that energy as heat to my environment. So when we look at how organisms use energy, we can talk about how much energy we bring in, and this could be in the form of kilocalories or big C calories. And oftentimes that energy budget in humans, at least, there's a problem in that sometimes it's not balanced. So we take in more calories than we actually burn, and then we can store that energy as fat. And that was really important during times when food was not necessarily abundant, specifically at certain times of the year. The ability to store fats was really important. So when we talk about some of the things that we use energy to do, we can talk about maintenance. So this could be, for example, like repair, right? So even like the simple thing of our skin cells being shed off and replaced by new skin cells. So just maintaining the body. Even our skeleton is actually broken down and rebuilt depending upon the forces that are applied to it. So we use a lot of energy in maintenance. One thing that we can talk about in terms of maintenance is thermoregulation. And animals, for example, have two different strategies in terms of how they regulate their temperature. So we could talk about those organisms that are endothermic. So endothermic means that you have the inside temperature. So you're using metabolism to regulate the body temperature. So for example, mammals and birds are endothermic. And you might also note that they now think that at least some of the dinosaurs, and birds are now classified in with the reptiles, they're kind of like living dinosaurs. Some of the dinosaurs actually seem to have had a lifestyle that was more closely related to endothermic mammals than, say, for example, what we think of when we think of, say, lizards or snakes. And so this is not necessarily warm-blooded versus cold-blooded. So that distinction is kind of incorrect. Okay. So this is versus ectothermic. And this means that they do not use their metabolism. And so one way that ectothermic organisms regulate their temperature, if they need to, is through behavioral thermoregulation. So they have the ability to move around in the environment. I'll just put thermoregulation because I ran out of room there, reg. And so this means that they can say, for example, if I'm a snake, I can go and lay on a hot road and I will become hot-blooded, right? So that will allow me to be able to move around in my environments and utilize resources that I wouldn't be able to do if I was very cold-blooded, right? So ectothermic organisms use other mechanisms for regulating their body temperature. Now, related to these two ideas is that endothermic organisms tend to be homeotherms. So I'm going to write this tends to be a homeotherm. That means that their body temperature tends to be relatively constant. The ectothermic organisms, sometimes their body temperature can vary dramatically depending upon their environment. It varies with their environment. So these guys are called poikilothermic organisms. And that just means that it fluctuates with the environment rather than staying constant. So it's important to realize that these are alternative strategies of using energy. So there's not one strategy that is better than the other. It's just how they use it, right? So being an endothermic organism has allowed mammals to move into environments that are very cold. So if you think about the Arctic, for example, you don't generally see very many lizards or snakes up there, right? So it allowed the expansion. But if you think about it, using your metabolic rate to regulate your body temperature is energetically expensive. So you have to think about it as cost versus benefit. And that is the idea of a budget, right? So what is the benefit you get from being able to regulate your body temperature? So this is just one thing that we use our energy for. We could also use our energy for growth. And maybe I'll switch back to blue here. So it could be growth. We could also use our energy for reproduction. We could also use our energy for storage. Maybe we need to store up energy for lean times in the year. And then we could also use our energy for protection. So say, for example, even the immune system, right, requires some protection. We might, when we think about protection, think about weaponry, right, or different structures of the body that helps to protect the body, like maybe an insect having an exoskeleton. And so these are all things that organisms use energy for.